Hello everybody, and welcome to Greg's Vintage Workshop, where I'm working to restore history one piece at a time. Today we got something a little bit different than what we normally have. If you all have seen my coil winder that I created a couple of months ago, we're going to do a shakedown of it today. It's going to get its first true test to see how good of a job I actually really did on it. Recently, Larry at Backtothefuture Radios had a radio that he was working on. I can't remember what the name of it was, but it was an older radio, either from the late 20s or early 30s, and it had two bad Interstage Transformers in it. And when I watched that video, I was like, well, heck, it might be a good job for my coil winder, give it a shot. So I reached out to him and told him that if he would like to give me a shot at doing it, that I would be more than happy to attempt to wind his coils for him. So he agreed, and I said, well, send me one and we'll see how it works, and if it works out then we'll do the second one. So that's what we did. He sent me the coil. He took it apart first, which the very first part of my video here is going to be him disassembling that transformer, and then the rest will be me working with it. So without further ado, let's get started.
This is T2 Interstage Transformer, and I've marked the secondary side, and of course the other two will be the primary, and as you can tell, the primary is the closest inner winding, and I think you can see the division of the windings. I think that from here out is the secondary, and from there in is the primary. But this is T2. This is the odd one, or this was the replacement. And this is how it's mounted to the chassis. The wires, both the primary and secondary, is down this way, and it's held together with these two plates along with this mounting bracket. And I'm going to try to take this apart. Taking the mounting brackets off, these two just plates hold the laminations together, and these they don't alternate, they just do that number. Let's see if I can get this off now. These may have to come out, maybe one or two may have to come out too. Oh, it's all going to come out together. I'm sure this is easier than it looks. sending these off to be rewound. I'm going to send this assembly here with a bracket and everything to hold it all together, and that way you will have the I know this is easier than this is plumb crazy. Anyway, I'm going to send the coil and this apparatus here. Well, that was brilliant. This way you can see the size and the E and the I and all that stuff. So. And it should hold together, and you'll get a good sizing and fit up and all that good stuff. But that came apart a lot easier than I thought it was going to. The other one I've got to drill some rivets out. But I think it'll come apart once that happens, because I don't think there's anything holding them together. So I'm going to send this along with it, and that'll give you the whole diameter and everything.
Okay, so we're going to be doing a recording of the first real wind job from my new coil winder. I've got two cameras that are going to be focused on this, one from the top where you can see the actual coil itself being wound, and then one from a distance where you can see kind of what I'm doing, and probably, I don't know if you'll be able to read that or not, but that's going to be the number of turns. So the first thing I had to do, he sent me his coil, and I went on Tinkercad, and after quite a few iterations came up with the former that I've got here, and I've got the E clip plates on there and all put together so that it would fit perfect, both in diameter this way as well as the width this way, because the primary is going to be somewhere between 5,000 and 6,000 turns, and the secondary is going to be somewhere between 15 and 16,000 turns. The wire we're going to be using is 40 gauge, which is basically almost as fine as a hair, maybe even finer. And I also made some specific spindles that fit my coil winder spindle tapers, so those will fit directly into that and put pressure on it. And I also had to redesign my spool holder in the back, so let me go over there and I'll show you that. Okay, so here we are looking at this side of the spool holder. That's the spool of 40 gauge wire. I built a new arm here. I built this brace arm here. I made a new pin to go across because the diameter of this particular roll was smaller. To show you a better idea of what I redid, this was the original arm and the original pin and the original spacers, and now we've got different arm and different spacers in there specifically for that roll. So my next step is going to be to put this on the actual arbor here. I'll bring some wire in and get it ready to go onto the former, and I will have to solder the first lead onto it and tape it to that before we can start winding the primary. So let me get that on there, and I'll get the lead soldered on, and then we'll come back. Okay, so what I found out, I didn't actually get to the winding operation yet because I wanted to feed the wire through my little feed tube and pull on it and just see how much tensile strength, if that wire, with a 40 gauge wire, was going to have enough strength to be able to withstand the winder pulling it off of that roll. And unfortunately what I found out was that the plastic shafts that were holding it created just too much resistance. Even though they were slightly smaller, I still had too much resistance. I sanded them with some fine sandpaper, made them a lot slipperier. It made a little bit more difference. Threw a little bit of oil on it, made a little bit more difference, but still just could not handle it. So what I've done is I've created some new pieces. I decided to go with ball bearings. So this is a new arm for over on this side with the bearing, and this is a new part I printed for this side, which will actually just, in this one's case, this just slides in here like that, and now I've got the bearing over there, and then when I put this over here I'll have the bearing over there. And I created a couple of tubes to put into the actual roll, and I'll be running a 6-inch bolt through the whole works, and the roll can roll on the ball bearings or it can roll on the bolt itself. Just depends on which has the least amount of resistance on it. So let me get that on there and we'll see what we get. Okay, as you can see here, there is the first two iterations for my coil winder. The one on the right is the one that I used originally to wind that small coil. The one on the left is what I created to wind the larger coil, 1 pound coil of Larry's, which it appeared to be too much drag on that plastic. I mean, it was just slightly a little bit of drag, but apparently too much for the 40 gauge wire, which is thinner than hair, I think. So I had to create new ones. So let's take a look at that. Alright, so the blue piece is the new piece, and it actually has a bearing in it. And the cross piece is kind of a brace, but it's also a way for me to apply pressure against some felt washers I have in there to increase tension on it if I need to, because like right now it's really loose. I don't take any effort to move it, and I can pull the 40 gauge wire against it, at least by hand. Let's look at the other side. So here's the other side, and in this side the bearing is contained in this white piece, and the white piece is made to slip right in the holes of the gray piece. And the reason I did it this way is because I've already got a hole in this gray piece that'll accept the pin that I would normally use, and so I just created a part that would slide right in there to hold the bearing. And then I've got a 6-inch bolt running through it, and the reason I created the new one over here, the blue one, is because it needed to hold the bearing, and it already had a plastic pin that was part of the actual print, so I had to make a whole new piece. So now I'm getting ready to put the former on to the winder, and I'll show you that. Okay, so this is the actual former, and I made it in two pieces that actually slide together. This is the female section, this is the male section, and they will slide together, and I'm going to put a dab of super glue in there to hold it all tightly together. But that's the way it goes together. I'll put the super glue in there and quickly clamp it together with my fingers in order to hold it in place. I've got the exit points for the wires. There's only 3 because one of them is going to come out the side when it gets to that point, assuming this all winds properly. So I'll get some glue in that, and I'll get it on the actual shaft here of the winder. And I'll bring you back. Okay, so we're winding here. I'm up to about 250 turns so far. I did some adjustments to get the traverse correct as could be, and my speed about right to get the right amount of turns going on there at once. Still doing a little bit of adjustment here. We're going to speed the winding up just a little bit more. So far so good. We haven't broke the wire yet, so that's a good thing. See a little bit of a bald spot right here, but I'll probably will fill in. Up to 500 turns now. I'm going to speed this thing up, the video anyway, not the actual machine. I think we're about the right speed right now, but I'll probably have to speed it up or cut to a little bit finish on this particular primary winding, but if it breaks or something I'll bring it back, otherwise we'll stop at 5,000. Alright, we're right at 3,600 turns right now. And so far so good, no issues have occurred, have not broken any wires yet, knock on wood, and everything's running smoothly. Okay, so I got the secondary coil set up and I'm in the process of calibrating the traverse. I'll bring you back when it's running. Okay, so we're at 10,400 turns, which is 2/3 of the way through. So I'm going to go ahead and leave this particular camera running, and then I will run it probably 10 times normal speed to zip through it. You guys can kind of watch it come to life in that final third in the video. Alright, we're getting pretty close, guys. It's we're taking it to 15,600 and we're at 15,150 right now. When I get to 15,600, I will try and hit the traverse and rotate simultaneously to get a good stop. And I might miss it by a few turns because it's turning fast enough, but if I do, I can unwind or add to it. So. $15.5, getting close. There we go. Stopped at 15,599, so I'll do an additional wind on there. And I will come back when we're ready to start putting that final lead on there. Okay, so I haven't shown you guys how I actually did the lead process, so I'm going to do it with this last lead. As you can see, or maybe you can't see because this wire's so thin, it has enamel coated, so I've got to get the enamel off or it won't solder. And the way I've been doing it is taking this small fine emery board of my daughter's and just gently raking it, put just slight amount of pressure on it and pulling it through. Because this wire is so thin, it will break if you put much resistance on it. So I pull it a few times, I try to rotate it, and I pull it and I try and rotate it. So let me finish doing this, and then I'll bring you back and show you what I do next. Okay, so next I have the lead I'm going to be using, and I'm going to solder the wire to pre-tin it before I put the smaller wire on it. So let me get that done and I'll bring it back. Okay, so I've got it prepared. I put a little liquid rosin on it, and we'll just take this solder right here and we'll just get some on there like that. Okay, next we'll take our wire here that we have hopefully gotten all of the enamel off, and I'm going to take it, if I can find the end of it, so small, and we're going to wrap it like this. Okay. Then we will take a little more solder, get the heat in there, and it should be soldered. Okay, so next thing I'm going to do before I actually tape everything all up is I'm going to take my ohm meter and ohm out between the this wire and the other lead. So let me get that set up. Okay, so I just ohmed it out. We're still connected to it, and we got 6.5K, whereas the primary was 1805, and the reason we're not 3 times the amount exactly is because as the spool got bigger, it used more wire, so there's more wires in the turns of the secondary than the 3 times, if that makes sense, because every time it got bigger, we were, let's say the primary maybe took 6 inches per turn. By the time this is done, it might be 8 inches per turn. But anyway, we got good continuity, so I'm happy. Obviously my tinning job worked. So the next step is to get the Kapton tape wrapped around this, get shrink wrap on this lead, get that cap on taped in, and then we're going to wrap the whole thing in some black cloth electrical. So don't mind the AC, but I've got the lead all connected, all taped in there with several layers of Kapton tape. I'm getting ready now to cut some of this black cloth tape to fit that, and I'm going to wrap it with that a few times as well. I think it'll give it a more finished, older look to it, so that it looks better in Larry's radio. So I think we'll do that now. Okay, there we have the final product, Larry. I hope you like it. Hopefully it's going to work out fine for you. I think it looks pretty good with that black tape on there that I put on there. If you don't like the white of the former, you can always paint that black or something too. So Anyway, I hope that this works for you, bud. So I guess this will end this coil winding adventure. Hopefully everybody saw that my coil winder actually works pretty good. If I can wind hair size 40 gauge wire with it, I can certainly wind things bigger and more easily. So from Greg at Greg's Vintage Workshop, thanks for watching.